Okay, in this video we will look at the examples of horizontally launched projectile problems. We're going to look at 3 problems here. I would recommend trying these problems on your own to see how you would do it, and then playing the video and watching the way that I would solve it. So pause the video after you've read the problem, then before moving on, try it yourself and then watch my example. First problem, if a ball is thrown horizontally off a 25-meter tall cliff with a speed of 8 meters per second, how far away from the base of the cliff will it land? Now, we know it's being thrown horizontally. So we have horizontal motion. The initial velocity is 8 meters per second. We know that the acceleration horizontally is always going to be 0. This will always be true for projectiles. Vertically, we know the displacement is going to be 25 meters. It's being thrown horizontally, so it's being thrown this way, so there's no vertical motion, so the initial vertical velocity is 0. This will change when we get to the projectiles launched at an angle. And the acceleration is 9.81 meters per second squared going down. These are both down. So I'm going to treat down as positive. In this case, I want to solve for delta x. Now I don't have enough information here on this side to solve for delta x, so I'm going to need to work with this side. The one variable that is the same on both sides is t. So if I could solve for t using the vertical, then I could plug that t into the horizontal and solve the problem. So delta x equals bit plus 1/2 at squared. So 25 equals 0t plus 1/2 9.81 t squared. So 25 equals 4.905 t squared. So we're going to divide 25 by 4.905 and get 5.0968 equals t squared. Take the square root of 5.0968 to get t. We get 2.26 seconds. So once we know that t for the vertical is 2.26 seconds, we know that t for the horizontal is 2.26 seconds. It's the one variable that can be the same both horizontally and vertically. So now we can use the same equation, delta x equals bit plus 1/2 at squared. Delta x equals 8 times 2.26 plus 1/2 0 times 2.26 squared. So this whole portion will become 0. So we're just going to do 8 times 2.26 and get a displacement of 18.08 meters. And that will be the answer to our problem. The key to these problems, as you see, is you must separate horizontal motion from vertical motion. And you must remember that the vertical acceleration is 9.81 down, the horizontal is always 0. So let's look at another problem. Cliff diver wants to dive off a 100-meter cliff, clear rocks that are 15 meters from the base of the cliff. How fast must she run off the cliff? So once again, we want to break horizontal and vertical into 2 separate parts. We know the delta x horizontal needs to be at least 15 meters. We know the acceleration will be 0. We need to know the initial velocity. Vertically, we know the delta x will be 100 meters down. We know the acceleration will be 9.81 meters per second squared down. We know the initial velocity will be 0. So we don't have enough on the horizontal side to solve, but we can use the vertical again to find time. delta x equals VIT plus 1/2 AT squared. Everything is down, so we're going to make down positive. 0 times t plus 1/2 9.81 t squared. So 100 equals 4.905 t squared. 100 divided by 4.905 gives us 20.39. So 20.39 equals t squared. T equals the square root of 20.39. We get 4.52 seconds. So we now know it's going to take 4.52 seconds for this cliff diver to hit the water. So that will be the same time here. Now we can solve delta x equals VIT plus 1/2 AT squared. So 15 equals VI times 4.52 plus 1/2 0 times 4.52 squared. This side all becomes 0 because multiplying by anything by 0 is 0. So 15 divided by 4.52 to get VI. So the initial velocity would have to be at least 3.32 meters per second. 3.32 meters per second would take this cliff diver right to the edge of the rocks. So the cliff diver would probably want to run just a little bit faster to make sure she completely clears it. One last problem. If a ball is thrown off the top of a platform with a speed of 5.8, this should be meters per second. Typo there. Now with these problems, you want to pause the problem for a second, try it yourself, and then press play again to see how I solve it. We want to break this into two parts. Once again, horizontal and vertical, and treat those as two separate things. In this case, we know the initial velocity horizontal is 5.8. The acceleration is always 0. The delta x, in this case, is 6 meters. The initial velocity vertical, since they're running horizontally, is 0. The acceleration is 9.81 going down. This is always true for the vertical. And we're looking for delta x. This time we don't have enough information to solve on the vertical side, so we're going to have to start with the horizontal side. Delta x equals VIT plus 1/2 AT squared. So 6 equals 5.8 t plus 1/2 0 t squared. This whole side becomes 0, so 6 equals 5.8 t. T equals 6 divided by 5.8. Which is 1.03 seconds. Now, once we have time, time is the one variable that applies to both sides. So we can put time over here. Now we have enough information to solve. VIT plus 1/2 AT squared. Delta x equals 0 times 1.03 plus 1/2 9.81 times 1.03 squared. Multiply this out, and you get a delta x of 5.2 meters. So this would be a 5.2 meter tall platform. Key things to remember: separate horizontal and vertical. Horizontal acceleration is always 0. Vertical acceleration is always 9.81 going down. The only variable that's the same for horizontal and vertical is time.